Hi, this is Kerry McNamara at Bossier Parish Community College, and today I'd like to talk to you about some very important types of chemical reactions that we see not only in chemistry but also in biology and in our day-to-day lives as well. And those would be acid-base reactions. Acid-base reactions are very important in industry, they're very important in our physiological makeup, and I'd like to go over some of the basics with you, identifying acids and bases, and then seeing some of the types of reactions that may occur with them. Now, acids and bases get kind of a Hollywood, especially acids, kind of a Hollywood reputation as being very dangerous substances. They burn through metals and wood and skin and clothing, and some do, many do, but many don't, and can be used in a more gentle way as well. So, to identify an acid-base reaction, the first thing you want to do is make sure that you have an acid. And acids are identified as starting with the hydrogen atom, or in this case, the ion. So here are some very common acids. This is hydrochloric acid, beginning with the hydrogen with a chloride ion. This acid here is sulfuric acid, also known as battery acid. Another very useful and common acid is this one here, phosphoric acid. And what I want you to notice about these acids is that first they all do begin with a hydrogen ion. So if we were to dissolve these into water, let's say, if these were solids, and they are often in the laboratory, they'll come in canisters as powders. If we dissolve them in some water, then what happens is, being ionic compounds put together with plus and minus ions, they simply dissolve and break apart into what they're made of. So this first hydrochloric acid example will break apart into the H+1 ion and the chloride ion. And what we usually do is designate them now being dissolved in water with the two letters AQ for aqueous. Same thing happens here with the sulfuric acid, except in this case, because we have two hydrogens here, we get two hydrogen ions and the one sulfate ion. And again, all of these would be dissolved in water, so we can label them AQ. And then we can see the same thing would happen here with the phosphoric acid. Let me kind of summarize this. Instead of writing the H 3 times, I'll just put three hydrogen ions, again, dissolved in water, and the one phosphate ion. So going back to the original formulas here, the reason that this first acid only has one hydrogen, the second one two, and the phosphoric acid has three, simply has to do with the fact that these anions that they kind of are attached to begin with have different charges on them. And these you can find either on your polyatomic list or somewhere in your textbook for these polyatomic ions. -2 charge on the sulfate, therefore it needs 2 hydrogens, and -3 charge on the phosphate ion, so it needs 3 +1 charges to add up to 0. And those are what acids do. In this sense, they're kind of hibernating. In their solid form, they're really not as dangerous as we might think. But as soon as they're exposed to water, they dissolve, and we don't need a lot of water. Sometimes just the water in the palm of our hand on our skin, the moisture in our skin, is enough to dissolve these and get them activated. And it really becomes the production of these hydrogen ions in all cases that creates the strength of acids. That's really the powerhouse of an acid, is this hydrogen ion. Looks innocent enough as it is, but actually a very reactive substance. Okay, and those are acids. So generally speaking, an acid begins with the hydrogen ion and dissolves in water into the ions that it's made up of. It falls to pieces, literally. Let's talk a little bit about bases, and we'll see a similar behavior here. Bases can be identified simply as also ionic compounds, but ending with the hydroxide ion, which is the OH ion right there. So there's a very common base, sodium hydroxide, used in such things as drain cleaner or oven scrubbing materials, foam for oven cleaning. Another strong base would be calcium hydroxide, sometimes found in some antacid tablets. Very strong base, though. And then another one, might be aluminum hydroxide. So again, we see the common feature with the bases is that they end with the OH ion. Now in water, we're going to see a similar behavior. They're simply going to dissociate. We could picture these as being solid for the time being in a powdered form, again, just like the acids were. And when they're dissolved into water, they simply, just like the acids did, they break apart into their ions. The common feature for the bases is that instead of producing an H ion, they produce the OH ion. So here we get the calcium ion and 2 of the hydroxide ions. Again, everything is now dissolved in water, so we can write aqueous. And then with this aluminum hydroxide, 1 aluminum and 3 hydroxides. The aluminum has a +3 charge, and that's the reason that we need to have 3 OH ions, again, to add up to 0 to make the charges equal 0 for the ionic compound. Okay, and that's the easiest way really to identify acids and bases. Acids begin with the H+ ion, bases end with the OH ion. In the next video, I'll show you what happens when these acids and bases react together in a reaction we call a neutralization.